Assalamualaikum and hi everyone. In this video, we will resume our regression analysis with another example here. The following data represent noise level and blood pressure rise from Journal of Sound and Vibration 1991. Let's perform a full regression analysis on the relationship between the noise level and the blood pressure rise. So let's answer this one. We already know what is our X independent, the noise level, and what is our Y dependent, blood pressure rise, is given in the problem. So now we can select the data and then go to insert, scatter plot. There you have your plot. You can change the axis title later and also the range of the x-axis. Format chart, right click, format axis. I think the unit here we can start from 50. Okay, so it's better. Okay, click plus, axis title, and also trend line. So you have trend line. And then I'm gonna change to make it more visible, the trend line. Okay, that's good. And then click the graph here to get the display equation on chart and the R squared value on chart. Make this bigger. Okay, good. Okay, I hope by now you are familiar with the scatter plot, trend line, and displaying the equation and R square. So from the equation, statistically, we can say that for the blood pressure rise, we can just write the estimated BP rise would be 0.1743 times the noise minus 10.132. As you might have noticed, it's minus. So we are going to interpret each of the coefficient individually. To move this bit up here. So from the trend line equation, we have y hat equals to 0.1734 x minus 10.132. So this y hat is BP and 0.1734 is beta 1 times the noise minus beta naught. Okay, so the beta naught is the intercept and beta 1 is the slope. As you might have noticed, it's the negative sign of the intercept, beta naught. So if we're going to interpret each of these coefficients individually, meaning that if there is no noise, meaning this part here is 0, then actually we have a negative value on BP reading here. Now let's see, it looks like a positive relationship, but we still need to see, and let's compute for our R. So we go to data analysis, and then we can select correlation, click OK, and here the input range, we shall select our data, and labeling first row, and for the output range, click select where you want to put your output. So let's say put it here, and then click OK. So now if we were going to take a look on the R squared value, we have a positive relationship and it's around 0.86. So our relationship here is positive, and based on the table for R here, okay, we have a table for absolute R with the interpretation. Here it is considered 0.86 is considered high correlation or a strong correlation with our R squared is equal to 0.7483. We can also say that 74.83% of the variation of the blood pressure rise is well affected by the noise level. So we can see that the relationship of the blood pressure rise is due to the noise level. So now we shall do our hypothesis test. So before that, the R squared and R is the strength analysis for the regression line. So to perform a hypothesis test, again we select data analysis, and then we can do our regression. Here click regression and OK. So the input Y range, select the data here, and then the input X range, select noise level, then label. So click output range. So the output range is where you want to put your results. So we click here and then click OK. There you have a summary output of our regression analysis. Here is the output of the regression analysis. So before we go any further on analyzing our hypothesis test, I'm just going to write here that we have our R positive value 0.86 with strong correlation. And our R squared equals to 0.7483 or about 78.83%. Then, before we go to our hypothesis test, I need to remind you about our hypothesis, about our null hypothesis. So we have hypothesis test. where our H naught is when beta 1 equals to 0, and our otherwise it will be H1 where beta 1 is not equals to 0. To determine these two hypotheses, we will need to see our p-value. So we need to go and look at our p-value, which is this one, the p-value. Format cell, bin number. So okay. So for this p-value, it's gonna be around 0.00001. Okay. So the last step is to see how can we accept or reject our null hypothesis based on the p-value. So I'm going to bring this to the bottom here. Is the null hypothesis when beta 1 equals to 0, and otherwise beta 1 is not equal to 0. So for beta, to reject our null hypothesis, p-value should be less than alpha value, where our alpha value is equals to 0.05. So from there, from this table, we can see that our p-value here is obviously smaller than 0.05. So we're going to reject our null hypothesis. Therefore, we can say that we have a significant relationship between the blood pressure rise and the noise level. So that's how we do a full simple linear regression analysis. Here is tab key that you can refer to the key points and the formula while you do the simple linear regression analysis. So you can try to apply what we do here using the exercise provided in the slides. So all the best everyone, and thank you.